Welcome back. Systems of equations, day one. First thing we're going to talk about is determining how many solutions systems have. Well, if we're talking about linear, there's only three possible outcomes. Intersecting, one solution. Parallel, zero solutions. Or a term called coincident. What that means is that a first line is directly on top of a second line. So we have one solution, zero solutions, or infinite solutions, because a solution to a system of equation occurs where the lines intersect. The easiest way to do that is by simply solving for y. In the first equation, subtracting 3x to the other side and dividing by 7 will give the resulting equation. Y equals negative 3 over 7 x plus 22 over 7. Likewise, in the second equation, subtracting x to the other side and multiplying by the reciprocal 3 over 7 will result in the following equation. Y equals negative 3 over 7x plus 22 over 7. Both of these lines are identical to each other, which is the third style of solution style, and that will be the infinite number of solutions. Noticing that this one is already solved for y, I will simply solve this one for y as well. Subtracting 5 and dividing 2 in the second equation will give you the following equation. Negative 5 over 2 x minus 4. Slopes of these lines are identical, just like in example number 1. However, the y-intercept is now different, which means rather than two lines on top of one another, we have two parallel lines. The number of solutions here, 0. Solving for y in equation number 1 will give you the resulting equation. Y equals 3 over 7 x plus 9 over 7. Solving for y in the second equation will give you y equals 1/2 x negative minus 1/4. Two lines with different slopes and different y-intercepts will give you a single solution. Recall that the vocabulary term for the lines in the first system is coincident. Coincident. Please pay attention to that. There is a possibility of seeing that vocabulary term on a test or a quiz. Okay, we're going to use substitution to determine if the given ordered pair is an element of the solution set. Well, all that means is that the intersection point between these two equations. So simply substitute the ordered pair 3, negative 10 in for the appropriate variable and use a test to determine if that is true or false. That is 12 plus 60, and that result should be 18. The answer to that is no, so I'm going to put a little X there. Now recall that if this was a check mark and this one worked out, that you would have to solve that one as well to make sure that it was a solution for both, because it must be the solution for both in order for it to work. So we will go ahead and finish this out. 3 minus a negative 10 should equal 8. Well, that's 9 plus 10 is 18. That is not true. Cross that off. The answer to this is no. Remember, you must have a true and a true statement in order for 3, negative 10 to be a solution to a system. Alright, we're going to use a table to solve this system. This is a little bit more complicated, or at least you make it a little bit more complicated than it needs to be, I believe. Please remember that for every x, the y's will be identical from equation 1 to equation 2. So if you notice, you're looking for the place where the y1 value is identical to the y2 value, and that occurs at the spot 3/2. Therefore, the answer to this system is the x value 3/2 and the y value -5/2. That is the solution. Please identify it in the table. Alright, following this, we're going to graph, and by graphing you want to solve both of these for y. In solving the first equation for y, you're going to subtract 4x and divide the resulting equation by 2, and you get y equals -2x plus 3. Subtract, or add x to the other side, and for the second equation you get y equals x plus 3. Your y-intercept for the first line is 3. Your slope is 2, -2, so I'll be going down 2 over 1. And I'll work backwards as well to get my third point. For my second equation, my y-intercept is still 3. This time I'll be going up 1 over 1, and I'll work backwards to find my third point. Then I will, as close as I can, put these lines into place like so. The solution to this system of equations is where the two graphing lines intersect one another, which is at the ordered pair 0, 3. Another way to use to solve systems of equation is by using substitution. Substitution works a lot like a game where one player gets tired and another player gets subbed into his place. So we will take one of these two equations and we will solve it for y. Taking the first equation and solving it for y, you actually get a much simpler result, and it's y equals -2 x plus 6. Now this is the tired player. This is the player that will be going into his position in this equation. Therefore, I will substitute, and I'll get -2x plus 6 minus 9x equals 1. Combine your like terms and get -11x plus 6 equals 1. Solve for x by subtracting 6, and I get -11x equals -5. Divide both sides by -11, and the x value for this equation is 5/11. Going back to one of the two equations, it does not matter which. I like to use this one because it's already solved for y. I'm going to substitute x back in, and I get y equals -2 times 5/11 plus 6. In solving that equation, y equals 56/11. Again, moving over here, we're going to solve the equation, and if you move this x value, you get y equals -3x plus 3. Over here, I'm going to take out the y value and substitute the x. Therefore, I get 2 plus -3x plus 3 equals -3x. I'm going to combine these two to get 5, and I get 5 plus -3x equals -3x. Now you see a problem, and that is that the x value actually cancels. Now this is a very important algebraic rule. Is this a true or false statement? The answer is it is false. Therefore, there is no solution to this problem. What this means is if we were to go back and solve this second equation for y, you would notice that the slopes are identical and the y-intercepts are different, which makes them parallel lines, which is why there is no solution. So in future, if you ever get a solution that looks like this, you know that it is not a true statement, therefore there are no solutions to that system of equations. Moving on to question number 9, we have a different way of solving it than substitution. That other way is called linear combination or elimination. Alright, so what you do here is you treat these as though they are large equations, and you look for a place where one will cancel the other out. Okay, one variable will cancel the other variable out. So the most important thing you need here is a sign change, and you need a coefficient that is the same. Now notice in neither one of the x or y variables is the coefficient the same. However, the sign change is there. Therefore, you could use either of the two variables equally as well. What I'm going to choose to do is I'm going to choose to change the x variables so that the coefficients are the same. Now remember, when you have a system, when you have an equation, you have to change everything about it, not just one value. So in order to make the 5 and the 2 into the same number, they need to be 10. Therefore, I will multiply the top equation by 2, and I will multiply the bottom equation by 5. Placing parentheses around the entire equation, I will distribute the 2, and I will distribute the 5 to all three of the equation, to the values in the equation. And I will get 10x plus 8y equals 12. Likewise, negative 10x minus 15y equals negative 5. Now I will treat this as though it's a very large equation, and I'll put it as a plus sign, and I'm going to combine these like terms together. That's the term linear combination. Elimination comes from the fact that the 10s will cancel each other out, therefore the x's will cancel each other out. I get negative 7y equals 11. Divide both sides by negative 7, and y equals 11 over 7 negative. Oh, sorry. Let's back up. I was wondering why my notes didn't match. That number is not 16. You guys are probably scratching your heads. That number is 12. Let's review. Sorry about that. Backtrack. All right. Now we have 7. And divide by 7, y equals negative 1. Now I'm going to substitute that back into one of the two original equations. I'll just pick the first one, no big deal. So it's going to be 5x minus 4 times plus 4 times negative 1 equals 6. 5x minus 4 equals 6. Add 4 to both sides. And I get 5x equals 10, x equals 2. Elimination. Okay? For time's sake, come prepared with questions 10, 11, 12, and 13 ready to discuss in class tomorrow.